Now let's look next. We move and continue this is the carbon dioxide transportation and storage. And this panel, we haven't talked about this area yet, but transportation is very important. There's an awful lot included in that, whether it's by rail, a truck, pipeline. Ensuring that the transportation of the carbon dioxide can be done safely and securely, it's important. What current protocols are in place, how can the necessary transportation modes exist without damage to fields or croplands, and how do we build trust in critical and necessary safety protocols? It is important, and there's some precedent set in some of the communities on transportation, and this is something new to add to that. After transportation, the inevitable next step is storage, and also known as CCS, or carbon capture storage, and we're going to learn about how that works, at what depths, and does Indiana have the geology to make that work? Our moderator today, Dr. Peter Saras, is a research assistant professor in chemical and biomolecular engineering at the School of Engineering and Applied Sciences at the University of Pennsylvania. Welcome to Indiana. He also is one of the lead authors on the transportation and storage chapters in the Roads to Removal report. His research involves techno-economic and life cycle assessments of carbon capture, utilization, and storage, and carbon dioxide removal systems, specifically in identifying regional opportunities for deployment. So this is a good one, and we actually have a little live demonstration. Yeah. All right, we're ready. This is it. So we're going to wake you up here. Thanks.
All right, thanks. Yeah, we brought props, so yeah, we'll wake you up post-lunch. Yeah, I'm Pete Saras. It's great to be here. I'm on the research faculty at UPenn for 3 more days. And I am transitioning to a full-time role at Carbon Direct at the end of the week. Been working with them for many years. Carbon Direct is advises clients on bringing quality removal to market. I like to think of us as the Gandalf, you shall not pass. And, so we enjoy that role very much. So thanks for having me. And I'm actually based in Cleveland, so it's better than driving to Philadelphia every day. Transport and storage. Right? So this is an important topic. I think it's, at least in the academic space, I don't want to say it was overlooked, but it's definitely not as much focus on the capture part. It's certainly not overlooked in the public eye. And so we want to talk through a lot of those things today, talk about them responsibly. We talked about many CDR approaches in the report. We recognize that the climate math is real and it is brutal. We're going to have to relocate billions of tons of carbon dioxide from the atmosphere to protect the most vulnerable populations, including many of ourselves and future generations, from the worst effects of climate change. If we're not going to put that CO2 in the atmosphere, then where? Right? We can talk about the oceans, we can talk about land. I think we really need to look legitimately and put this in the subsurface to make sure that it is stored durably and safely for years and years to come, so that we're not bearing that consequence and just kicking the can down the road. In fact, one of the greatest outputs of the Road to Removal report, in my opinion, is the mapping of geological storage, which looks at existing and prospective storage with costs, which I think is an invaluable resource for folks who are looking at where this can take place and how much it might cost. So from a project developer standpoint, I think that's a wonderful resource. As you saw when we had a map of Indiana, that it is entirely covered. All right, it is not the U.S.'s geospatial opportunity. About 50% of the United States is covered with viable storage, and 22% of that being very low cost. Indiana has a great opportunity for storage. It doesn't mean that we won't need to move CO2 and consider moving CO2. You might move that to get to lower cost storage basins. And transport is not just about moving CO2. We might need to move other resources like biomass. I know we didn't explicitly cover it in the report, other things like rocks, that might be part of our climate strategy. We've done a good job, I think, in the last 2 days of distinguishing between carbon dioxide removal, which takes CO2 out of the atmosphere, and carbon reductions and the vast technology space that can help us decarbonize, which limits the amount of CO2 that we would add back into the atmosphere. But we also recognize that these two approaches are inextricably linked. Not only will our success in decarbonization dictate how much CDR we'll need to do to achieve our net zero goals, but in many cases, like for example with CCS, that transport and storage infrastructure can be shared, and so that may also dictate what the logistical and geospatial opportunities look like. Our group at Penn focused on the transport, and we've got experts here to talk more through storage. I got into transport many years ago when I was hearing stories out of California that the pipeline was going nowhere, and that we needed to start really strongly considering other modes, and the fear of putting all our eggs into that one basket, particularly when public acceptance wasn't very strong. And I think we're seeing some of that rear its head today. So we studied for the report movement by rail and trucking and even barge, which move CO2 as a refrigerated liquid, and then also pipeline, of course, that moves CO2 as a high pressure supercritical fluid. Pipeline is at scale still the most cost-effective option, but we recognize that is not always the case at lower scales, and some of those scales that would be more relative in the near term. For Indiana specifically, both rail and trucking could be viable modes of transport for not only CO2 but biomass. We also recognize that pipeline has been suggested by other reports to help with the massive BiCRS opportunity within the state. But there are still trade-offs. I mentioned public acceptance, right-of-way, permitting, and the safety profile of these modes all come into play. There are still other trade-offs, including jobs and local economic drivers, and we will always need to make sure that we're examining these transport routes and that we're not exacerbating harms along these transport corridors. I think the main takeaway from the report, which maybe wasn't groundbreaking, is that if you were asking me, the best transport option is no transport. We showed in the report that there are so many opportunities to co-locate these projects with viable storage, which can either minimize or reduce transport altogether and just go straight down into the subsurface. So with that, let's get into our experts and our panelists. First, to my left is Susan Hovorka. She's a senior research scientist at the Bureau of Economic Geology, Jackson School of Geosciences at the University of Texas at Austin. She has a bachelor's in geology from Eartham College and a master's and PhD from the University of Texas. She has worked on diverse topics related to water quality protection, waste storage, embedded salt, and reservoir characterization. Her current research focuses on assessment of effectiveness of subsurface geological sequestration of CO2 as a mechanism for reducing atmospheric greenhouse gas emissions. Next to Sue is Steve Whitaker, Vice President of Subsurface at Vault 4401. Steve has 20 plus years of experience in geological characterization and the development of carbon storage sites in Canada, Australia, and the USA, including leading several carbon safe projects and other CCS projects toward Class 6 permitting. Steve has served on multiple technical reviews of CCS project and is chair of the ISO working group on geological standards for CCS. I was just gonna pause because there's a lot of acronyms there. So we've got carbon safe, SAFE, which is Storage Assurance Facility Enterprise, ISO, which I never understood. That's the International Organization for Standardization. I think iOS was taken. And then maybe you'll get into Class 6 in a little bit. And finally, David Bousman. David has a bachelor's degree in political science from DePaul University and a law degree from Robert H. McKinney School of Law at Indiana University. David serves as general counsel for the Indiana Department of Natural Resources after previously serving as the agency's legislative and public policy director. In his role at DNR, he manages DNR's legal team and works with DNR staff, members of the Indiana General Assembly, the governor's office, and local, state, and federal agencies on a wide range of conservation issues, including carbon sequestration. So panelists, welcome. Sue, let's start with you, and we've got some props. Maybe you welcome home first of all.
Yeah, thank you very much for welcoming me to Indiana. My family, my grandfather's farm is in Gibson County, and my grandmother's or vice versa. My grandmother's farm is in Posey County. I'll be seeing my cousins. We'll be talking about our farms for dinner. Wish me luck. And my parents were my grandparents were pioneers in East 58th Street when it was a new subdivision. They built their house here in Indianapolis. And so I do feel coming home, even though I'm from Texas. The Bureau of Economic Geology is the state geologic survey. So I don't know what that makes me university state person. I've been working on CCS for 25 years, I think. And I did the first injection I started critical, thinking, maybe this wasn't a good idea. Maybe we didn't really need this. Maybe water wouldn't be safe. And I have convinced myself it works. So I'd like to try to convince you in a very short period of time so that you can become informed people about it. We saw it works. So let's see, I do this and I'll start the thing. Next. Pointed at something.
So they have to be.
There we
deep
go.
enough
So this is a movie.
and isolated from fresh water, and they have to be shallow enough so that you're still keeping those spaces between the rock grains and they're not getting squished. That's usually depths greater than half a mile and less than 3 miles in the middle. About 1 or 2 miles deep is the ideal location.
So this is the depth. So now I want to show you how we know. So we have the layering. People say, how do we know it's not going to come up? Look at that graph. It's a stack of diapers. It's not coming out because it's a stack of both absorbent and non-absorbent layers, which will retain fluid. It's not, think about how far away a mile is from here. Put solid rock in it. That's one reason we're confident of the permanence. The other thing, this diagram shows it going to great depth. You see the fresh water up there at the surface. The fresh water is the protected resource. Maybe we'll talk more about that. It has to be protected during this whole process. I was worried about it. It is. It's effectively protected. The other thing I want to emphasize to you is this is in between the sand grains. So sometimes we draw a cartoon of CCS and we put it right under the house because it fits better on a page. No. I wanted to show that movie way, way, way down. When you work on a well and you make measurements and you start a tool on a spool going down to measure something at depth, you can go to lunch before it reaches down a mile. Think how long it takes. A mile's a long way. The second thing is not intuitive to people. Most people think rocks are solid. I'd like to convince you that they're not solid. Would you hold this for me? Sure. All right, I'm going to come out here and show you. So, will you guys help? It's late in the day. So I brought some rocks. All right. Would you be willing to squirt this rock with water and tell people what happened when we squirt with rock? Anyone know? Yeah. Pass these two things around. I'd like you guys to get to experience this personally. People think it will go in there, and please pass it around and share with anyone who wants to look at it and see the water going in. And now it's not intuitive how this is happening. It seems a little suspicious. So I want to blow it up, make it more visible. So this marble jar. This jar is full of marbles. I bought them the marbles are solid, and they're but there's spaces between them. So if we look at that rock in closely, we will see the spaces between it. This is where the fluids are and the CO2 can move. So, all right. If you won't drop it, I'll let you pass it around. We are very careful about not dropping things. So you can ask us questions about how we do safety to make sure that it's not going to. Now, not all rocks will accept fluids. This, for example, is a rock that will not. Anyone want to see a rock that will not accept fluids? Some of you have the misfortune to live in areas with rocks that will not accept fluids. The layering between the yes, I will, and no, I won't, is what makes the grade. Here, and I'll send the other one around because you can use your water bottle. Don't put juice on it. I don't want it to smell bad. All right, so So why is this significant? It's because of non-wetting phase hysteresis. All right, explain that. It's why you have to do your laundry. Porous media that most people are familiar with, it's your clothes. So if you have a porous medium on, you can try it. You can blow air through it. If you have the misfortune to drop your lunch on it, now a non-porous media like a table, you can drop something on it, you can wipe it off, it's out. A porous medium absorbs the fluids and won't give them up. You can try you drop it on your lunch on your shirt, you try wiping it off, you're gonna have to take it to the laundry. So the subsurface, which is a porous medium, holds CO2 like your laundry holds it holds water or other fluids. I think that's all. Is this what all I've got to show you? So we'll be sure because of the layers and because it's stuck between the sand grains. Did I convince you of something? I hope I convinced you that this is credible. So I think that's me. Oh, where are sedimentary rocks? Okay, so the sweet spots for sedimentary rocks are across the U.S. That's it. Do we want to talk about this? Why don't I stop and you want me to talk about this?
We can, yeah.
Do you want me to? I will. So people worry. I don't know why. To me, it seems very safe, but maybe it's because it's unfamiliar territory. We've been doing a deep well injection for about 100 years. The reason you don't know it is because it operates quite nicely. So several things to know. CO2 doesn't catch on fire, it doesn't explode. But if you damage a pipeline, it comes out with energy. It's not an explosion, but it comes out energetically and spreads out on the ground. It's cold. I've done it. Ask me, I'll tell you about what it looks like. It creates a fog on the ground. You can see it. And you can walk around in it. It mixes with the air, and we put on monitors to make sure we're safe, but it's not as dangerous as people think. Will wells leak? The operator must prove that the wells are properly constructed, manage or plug. They have to before they can start injection and during injection. And people wanted to talk about earthquakes. Again, this is required. We have to consider, everyone who wants to do a project has to consider seismicity and what's going to happen. We have a lot of tricks in our trade. Mostly we can do it, see if we can test the strength of the rocks down there by pushing on them, mini frac called, and we see what their strength is, and that lets us know how much we have to inject less. It's like a regular safety precaution, like a seat belt or something. All right, not questions.
Thanks, Sue. That was wonderful. Steve, maybe you could talk us through some of your work at 4401 and what opportunities, implications you see in the Midwest and Indiana specifically.
Sure. Well, I'm Steve Whitaker. I'm a geologist. That might be obvious because I also brought a show and tell, as typical with geologists. So my role with Vault 4401, and you know the genesis of that name now, is really to, I guess, describe the vault. That's what my team works on, and the vault is really around the caprock, the reservoir, and actually the bottom, the whole basically environment that we'll be using to store carbon dioxide. We have a team of, it's a pretty diverse team of technical experts. You need geologists, geophysicists, reservoir engineers, a whole gamut of technical specialties to really engage in this and fully describe these sites. Sue's kind of given a good idea of kind of the aspects that we really want to focus in on to do this. But basically what we see is a really good opportunity in the Midwest and Indiana. We're pretty bullish on Indiana in terms of its geological characteristics. Has great storage capabilities. Yesterday Deputy Administrator McCabe mentioned driving across Indiana and looking at the extent and all the hours she was driving along on the surface. But the same thing exists below us in the subsurface. We have the same kind of area below us with geological formations. And not only is it that surface bit, we have volumes, and some of these reservoirs are hundreds to even 1,000 feet thick, certainly as you get into Illinois at least. And in some instances, there's multiple layers that we can use, so you get sort of stacked opportunities. So the volume for storage is immense in the subsurface, and that's one of the things I think that we often struggle with as geoscientists and geologists, is to describe to our stakeholders and regulators and policymakers the scale at which we work on and which exists in the subsurface. Hugh, my colleague Hugh, mentioned this morning about our work with stakeholders and trying to educate them, and this is part of it. And Sue's video really highlighted a lot of it, is to try to emphasize the depth, how deep it is we're really working on. These things are incredibly deep. It's a mile deep, as you mentioned, but they're also very extensive. And one of the units that we work with here in the Midwest in Indiana is the Mount Simon Formation. If you've been at all in this, you've heard the Mount Simon Formation mentioned. It's the deepest sedimentary formation. Below that is what we call the basement, the crystalline rocks, which are not suitable for storage. Those are the ones which you could not inject into. And so we look at the Mount Simon is the deepest of those. And I also brought a sample of the Mount Simon here this is from Illinois, pardon me, but it's pretty similar to what you find here. And so this is, you look at this and you say, people often have the idea, well, there's caverns down there, there's stalagmites and stalactites, and the CO2 goes in there and it's sloshing around. It's not, it's in this. And so this is what contains the CO2. And so that is part of what we have to describe to our stakeholders and get people to understand. But describing this and what the nature of these rocks are, will they take the rate of CO2 that you need to inject for a given site? Will it contain it? What is the capacity? And as I mentioned, the capacity is vast in these particular rocks because they're laterally continuous. Describing the caprock characteristics. So, a lot of what we do is based on oil and gas knowledge, but there's a lot of differences to do with carbon storage. And one of those is understanding what the caprock is like, what the pressures are going to be in the reservoir, how do we mitigate any occurrence, instances of induced seismicity, which was raised earlier. There are methods that we do that. So there are regulations involved that permit, have to limit the pressure buildup. We monitor that on a regular basis. There's aspects within our Class 6 permits, which maybe I can get onto later, but that address all these kind of instances that may happen and what we would do in the case that something like that would happen. But basically, our role is to do this, is to describe this safely, make sure that we have sites that are amenable for the scale of work that we want to do. Every state is a bit different. I had a good conversation at lunch with a couple of new colleagues that we discussed how you would scale up these projects. And really, we design our projects around the amount of that's associated with the specific ethanol plant. That's what we design it for. And also trying to minimize the distance that we would have to pipeline it. So we are lucky here in Indiana in that we are able to co-locate, as you were mentioning earlier.
Thanks, Steve. And I also work with geologists, and they are always carrying rocks. I don't know why. They're terrible to hike with because they stop every minute. David, from a regulatory perspective, we heard earlier issues about pore space rates. Maybe you can tell us a little bit about what you're hearing.
Sure. Well, I'll apologize. I don't have any rocks. I'm the lawyer on the group, so sorry about that.
You can use this one.
So the discussion, I think, for Indiana was alluded to earlier, has really been a property-focused discussion. I think for those watching the Midwest, it's not a surprise. I-states usually follow each other, very similar to the conversations. And so a lot of the conversation, as it has related to carbon storage and as well as transportation, has focused on property rights pieces, not just from the landowner perspective, but we are also a blessed state with coal, oil, and natural gas as well that we have regulated within our department for many years. So usually the first question I get when I've talked about carbon is, why is DNR talking about carbon? And then when I begin to describe it, it's looking at it from a natural resource management perspective as well as from a property rights standpoint, and then the light bulb usually clicks at that moment. So DNR's role as it relates to carbon storage and injection is really in two areas. One, and has been around for about 13 years, is our carbon pipeline statute. So we have a statute that lays out the requirements to construct and operate a CO2 pipeline in the state of Indiana. Works through the requirements, but then also gives the use of public right-of-ways as well as eminent domain for the construction of that. I think Indiana is one of the leaders nationally with this discussion because we also have in our statute what I would kind of almost call like the preamble public interest, that carbon storage and capture is in the public interest for the state of Indiana. And that goes to a big piece when it relates to the use of public right-of-ways and eminent domain. More recently then, I would say kind of as a result of a lot of the conversations that we've heard earlier with federal dollars and programs coming online for CCS, in 2022, we had House and Act 1209 that was passed, and that really then put DNR in the discussion for the injection piece. And again, why us is wanting to make sure that we were being able to also make sure that our natural resources were being appropriately managed. And so our carbon storage program is actually housed under our Division of Reclamation, which includes our oil and gas as well as our coal program. So again, being able to look at that all three, together from a subsurface standpoint and that natural formation of it. So we have spent about the last year working with industry and developing regulations for our program. Neither under the pipeline or the injection have we received any applications yet, but we're working through getting those regulations in play. And the same thing with the injection is really going to be focused on, having the pore space being secured. I think Andy had mentioned on the panel earlier, we have a 70% threshold for integration or forced pooling. So we've worked out those guidelines as well as what's equitable compensation for pore space. For that. And so really working through that, we're not going to be into the water quality jurisdiction. That's not our lens here, but we'll be ready hopefully in the coming year with some regulations in place to have the industry running going forward, because I think we are really primed, as we've talked about, of across the state of seeing opportunities.
Thanks, David. Maybe I'll just kind of open it up to the panelists in general, and then we'll open it up to the audience. I want to make sure we have some time for audience questions. I think in terms of the social license for transportation and storage, education is such a huge component of that. So I appreciate you both kind of demystifying the subsurface and what it looks like. Are there other aspects here that we could get into? Often we hear about how do you control CO2? How do you know what happens to it once it's down there? What happens if it gets into our groundwater, et cetera?
So I'm interested in I'm a groundwater person. I'm interested in what happens when it gets into the groundwater. I took a large number of master's students and some aquifer rocks and bubbled CO2 in them. And we thought that we would release, because the CO2 is low pH, so it's carbonated water. That's what gives you the tang when you drink a carbonated beverage. You know how Coke goes flat? That's because it's lost that tang. So that's a pH tang. So we thought that the carbonated water would strip things out of the aquifer rocks. And I have to tell you that my students were bitterly disappointed because what they got was nothing. Changed a little bit of alkalinity because some of the carbonate, the limestone grains dissolved, and so it reached saturation with the limestone grains that were in the rock. And whatever was in the limestone came out in solution. That's already what's in the water. CO2 is not very harmful to water. Now, it's forbidden to release it. Why? Because that's the basis of all of our underground injection. You may not let fluids from the deep subsurface come up into the underground sources of drinking water. May not. So it's forbidden. Even if it's not harmful, it's forbidden. Also because we're using it for atmospheric benefit, so that in the regulatory environment, having that must not come up is very valuable to demonstrate the permanence. But people who are worried about groundwater don't need to sit on the edge of your chair. Groundwater is a protected resource. It's very important. It's very important to me. I was unable to damage it. Not to say that it will ever not be damaged, but one can test for the hazard easily. Let me know if you ever find one that's a problem where the CO2 interacts with it. CO2 is running around in aquifers anyway.
Well, and I think the Safe Drinking Water Act and underground injection control, right? Perhaps Steve or others, you want to comment on what Class 6 is?
Well, sure. Class 6 is one of the UIC underground injection control classifications of wells, obviously, and it is designed specifically for carbon dioxide injection wells. And it is the most recent of the classes made, and it came into effect about 2011-ish. So the rules, so it's pretty recent, but it's extremely, they're very detailed and very weighty documents that have to be prepared. But ultimately, it's designed to protect underground sources of drinking water. That's its ultimate mandate. And so a USDW, underground source of drinking water, is defined as something that's 10,000 parts per million total dissolved solids or less. So drinking water is typically nowhere near that much, but we have to protect those. So that's what the Class 6 wells, what the Class 6 permits are all about. They require months and months and months of work and many dollars of data acquisition that's required to satisfy these requirements at times. We've submitted now 4 permits for Indiana, Class 6 permits, and they're in review right now. One has been in review for over 2 years, and so they take a long time to be reviewed. They have a real range of technical components, so there's a lot of, there's geology, there's geophysics, there's engineering, there's financial components to it. So it takes a lot to review them. So the EPA has to outsource some of it, and there's a lot of work that goes into it. But basically, that's what the Class 6 permits are. They will give us the first stage. When you get the permit, you're allowed to drill your well. And then you drill your well, you have to get those results and resubmit that to the EPA for further analysis, and then they will give you permission to inject. So it's not, you just don't get these things with the snap of a finger. It's a lot of work.
Oh, maybe one last one, and then we'll go to the audience. I think we'd be remiss if we didn't address recent news with ADM. I know, better. That's if you feel comfortable talking about.
I will. Steve knows more details, but I've read carefully the public information, so I can talk freely. A little informed by having struggled with a number of wells myself. The ADM project started with a research project and designed a well to find out everything that researchers wanted to know about fluids. When they wanted to sample fluids at many depths, so they opened many depths in the same well. When they moved to the commercial project in 2017, they still wanted to sample multiple depths, 3 depths. So the single well was trying to get everything for everybody, more than EPA requires, a lot more than EPA requires. The problem they had was a plumbing problem. Wells are big pipes. They work just like ordinary plumbing. They're sort of annoying sometimes, but you call a guy and he brings out the stuff and fixes them. So they had the well had problems with its gauges. So they called in the professionals who came out and worked on the well, and they decided that they were going to have to pull the whole completion, everything that was in the well out. They set and this was in 2003. In 2023, they set bridge plugs above the injection zone. So, and then they went back to take a look at it and say, let's refix this well to see if we can put it back in service, collecting information again. And they found out some fluids had migrated in 2023 from the deep zone, Mount Simon, into a shallower zone. So 7,000 feet to 5,000 feet. It's not leak. Don't say leak. It didn't leak like dripping faucet on the ground. It leaked, it migrated, or cross-formational flow. It wasn't allowed, so the ADM had to report themselves and say, we did something that we weren't permitted to do. However, nothing happened to the groundwater, nothing happened to the surface, wouldn't, couldn't, didn't. The reason it happened was because it was such an ambitious well to collect so much information in one well. Now, that's not how we do them anymore. So it's easy to prevent. This problem is already solved and won't happen again. I'm a little confused why there's such a big fuss about it.
Yeah, just a little context too. I mean, I agree exactly with what Sue said. This was a research project initially. The well was part of that research project to do with this zone sampling, and they worked on it, and they just that would not be done again. And so the whole way they do these wells is not something that we would do. We would have a dedicated well that would sample the above zones. So these monitoring wells want to sample in the reservoir and right above the cap rock to see if there's any leakage. These wells were designed to do all of that in one well. It's too complicated. You would just have a dedicated well that would drill down to the top of the cap and sample there. It wouldn't go through anything, so that's there. And the other well, the deep monitoring well, would not have any other perforations. It would just sample in the reservoir and be cased fully. So nobody would do those kind of wells again. It was basically part of the research project.
Well, I appreciate it. And just for folks who are maybe unaware of what ADM is, maybe it kind of caught up through those comments.
It's much more fuss than actual problem. I think because a lot of people are watching now and many people are anxious or opposed.
And I think it's obviously very close to here, and it was a project that was incorrectly reported as an incident that was incorrectly reported as a leak. So I wanted to give you an opportunity to.
Yeah, and it's also a project that's often alluded to as here's a successful project. Now with this, but it still is a successful project. I mean, it's demonstrated that the geological storage works.
I know a dozen other projects that had equal problems, including my own, that are, we learned a lot in early projects about what to do right, what to do wrong. I can tell you all of them. None of them have hurt water. None of them have hurt people. All of them, the learnings have gone forward to a more mature, so we won't go more mature, safer operation. Will we ever have another incident? Yes. Will you ever have a plumbing problem at your house? Yes. What will you do? Call a plumber, get it fixed. It's that mature.
One of the things I would just say from the state perspective that I think, again, looking proactively in the future is after a Class 6 permit has been released, you get the post-injection site, there is a process that DNR is going to have to issue certificate of completions for these projects, and the state's going to take over the ownership and liability for the stored CO2. But one of the, again, foresight was we have an 8-cent per ton collection that's going to be occurring during these projects and injections that will have basically a trust fund that, if there is a issue with the plumbing, that the state can come in and be able to remediate that. Again, showing kind of the public benefit of that the state has recognized with the storage of CO2. So I think that's something that puts us as a leader from a state perspective, is that foresight of looking in and then having this trust fund that will be protected from swipes. It'll be a dedicated piece to that I think really should help put at ease projects going forward.
And I just want to also say that in the Class 6 permit, to get this, you have to demonstrate financial responsibility. So you have to have money up front that would cover any kind of incident for your project, whether the company goes away or whatever. The money's already there. It has to be there before you start to inject a well, and certainly before you start to inject CO2.
Well, with that, let's turn it over to the audience. Do we have any questions?
Good afternoon, Jared Apple with Patriot Engineering Environmental. I was curious your guys' observations or insights, especially in private sector, towards technology advancements, more towards competition or collaboration. Is this kind of a race to the moon type thing, or more of an international space station?
So I'll take it from the government side of things with this. I've been extremely pleased with the collaboration that the industry has had. When 1209 was placed with the agency and we were given rulemaking, our team immediately set out for, we're going to do this right. And the collaboration that we received from both the landowner side, from the specific project side to the integrating side, just has been very collaborative. Obviously understanding that there are projects that have certain business model that you don't want to necessarily share with your competitor, but I can truly say, I think from the government side, we've been very pleased with the collaboration and the fact that everybody wants to get this right. They want to make sure it's right for the industry as well as for the landowner as well as for the state government. And so I think that from the government side of things, I've been very pleased with.
Yeah, and from our perspective, we want to see everybody get this right. So certainly the service companies, those that have different monitoring technologies and that they're very competitive. They want their products to be used. We want everybody to be successful. And it's not that we're opening our books up and saying, here's what we're doing. But we do have communication, and we just, if we would help people out, they would help us out. It's a pretty good group right now within this space.
I just got back from an international meeting in Calgary, 1,500 people, 800 abstracts and papers, a lot of discussion.
Yeah, and I'll just add, I think that competition is great and innovation can get us out of this, but I think we also need to look at turnkey solutions today. We see a lot of the bottlenecks aren't necessarily in reinventing the wheel, and we need to make sure that experience from other sectors can come in and help kind of build this, because I think sometimes we act like we've got a lot more time than we actually do.
Hey everybody, Ian Champ, Clean Air Task Force. Thank you all again. It wasn't a leak, it was a migration. Appreciate that. And my team works on this a lot, so this isn't necessarily for me, but again, there are a lot of students in the room. So there's a lot of mis and disinformation out there around this topic. It's also just new for a lot of people. So I'm curious if each of you wouldn't mind taking a minute to just kind of reflect on like the information that you've got, and if there are any really reputable sources or outlets that you would go to or recommend people go to just kind of learn and get the actual facts, the language that they should be paying attention to, the buzzwords that they should kind of like be setting off an alarm in their head, those kinds of things, so they can be a little bit more informed as they review this.
I have a sticker. You can have a sticker of where to get. So now I have a DOE grant to get information out to people. It's a 6-university consortium. Our logo, anybody can have it. It's putitback.org. It's plain language information and targeting students and teachers, 7th grade knowledge of science to get information out. We're one month into it, so don't expect the moon yet. But we're doing a lot of things. If those of you who have fact sheets, want to share them, we have a fact sheet brokerage as well as a lot of information, including make your own marble jar to show these things. Anyone want to? I'll give you a sticker. You deserve a sticker.
Look at that.
You deserve a sticker too. You're doing.
I've already got one.
You got one. Okay.
Well, I'll take 2. I think just to add on to that, there's a number of pretty reputable sites. The Global CCS Institute generally has pretty good information. And the Department of Energy has been sponsoring research into CCS for 2 decades. Both of us have benefited from that quite a bit. And so there are regional initiatives. There's 4 active regional initiatives, and each one of those has a website with information. Previous to that, there were 7 partnerships. One based in Champaign, one based in Columbus, and they kind of intersected here in Indiana. So Indiana got the benefit of both of those. But there's lots of information on reputable sites, and you can find a lot of misinformation on a little more spurious sites, I would say. But just a little searching around, I think you can find lots of good information.
So I'll start with not social media, but I think from our perspective, one of the things that we've talked a lot about is that while the Class 6 may be new, the technology, we've been using pipelines for decades. Most of us have a natural gas pipeline pretty nearby for the state. So the technology that's there, while it may not have been used for CO2, we may not be, injecting CO2. We've been using, CO2 for enhanced oil recovery. We've been, re-injecting for natural gas storage. So those things to me, I think, are one of the things that we can talk about, certainly from our department end of we've been around this for decades and trying to, I think, maybe destigmatize kind of the boogeyman mentality about it.
Yeah, and I'll just add, I'll plug for our report, erosion removal. At least in our transport chapter, we did risk profiling of all these modes. And I think a lot of the narrative, we talked about kind of disinformation, a lot of narrative is built around a focus on the severity of outcome, but that's not how we risk profile. We risk profile by a combination of severity and likelihood. Right? That's what makes air travel the safest mode, despite the fact that there could be severe outcomes. So I think responsible messaging in that is really important. So we tried to lay that all out. And I'll also say to maybe younger people in the room who are going to actually carry us out of this mess, don't be shy about reaching out to myself or other academics or anybody on stage or anybody in this space. Go directly to the sources. People are spending their lives dedicated to studying and understanding and communicating these things.
I'll give you a sticker.
Get a sticker. Okay, yeah. We have one more question.
Hi, Greg Zeller with Wabash Valley Resources. So we do have 2 Class 6 permits, and we're just about starting to drill the wells. But I've had 25 years in government, and people don't trust the government, which we're not required to do. They trust companies even less. So when you're talking about how do we get the public at least enough true information, something that's more than just online, but how do we get to that with third-party validators, with people that they'll listen to? Because I'll say we could have done better, but we still have people who will tell me, I don't trust the science. So you're welcome to come and visit and try your hand at it, but we've been at it for a few years now, and people will just tell me they will never trust the science, government, or the company. Any help?
There's been a lot of discussion in our space lately if we are focusing too much on a futile fight in combating kind of misinformation, disinformation for those reasons. But I still want to believe that education is the key, honest engagement. So for me, that's getting out of the lab and getting onto the ground and talking with real people and what their concerns are. It's creating kind of educational material and just kind of demystifying these things. And honestly, we're in chicken egg, but actually seeing it work and demonstrating it, getting these things deployed, so much coming out of Department of Energy to help do just that. Seeing is believing, and as you believe their own eyes, let them be the judge. So I think that's really valuable in kind of moving forward. Well, if you didn't get to ask, or if we don't have time to cover them all, please tackle us. We've got props and stickers, and happy to address any questions that you have. But let's take a moment to thank all of our panelists.